12, we've got a function, we've got a shaded area. Hopefully straight away you are thinking integration. Okay, that's where we are going to end up with this question. Right, let's have a look at part A first. So, figure 2 7 and the straight 7 and the straight 7 and the straight 7 and the straight line y equals 2x plus 13. Find the coordinates of the points where the curve and lines intersect. Intersection of two functions, we've got to set them equal to each other. So we'll go 2x squared plus 6x plus 7 equals 2x plus 13. And we're going to solve. So we'll shift that to the other side. Plus 4x minus 6 equals 0. Let's simplify this first. Plus 2x squared plus 2x minus 3 equals 0. Then we can factorise, so we'll have x plus 3 and x minus 1. So my two solutions, x equals minus 3 and x equals 1, which, looking at the graph, quite happily could make sense. Okay, I want the coordinates, so please don't drop silly marks by not working out y. I'm going to substitute it into the linear function, going to be far easier. So when x equals minus 3, we'll have 2 times minus 3, which is minus 6. Add on the 13 to give us 7. And for when x equals 1, we're going to have 15. Okay. Right, next little bit, what we are looking at is actually, let's just to make sure we do get the marks, let's write them as coordinates as well. So we'll have 7, 3, 7, and 1, 15. Right, second part, find the area of the shaded region. Now, hopefully, we can remember when you integrate, so if I integrate between these 2 points, which obviously I do now know, that's going to give me this red shaded area here. Okay. Now, if I want the bit between the graph and the line, I've got a trapezium here. Okay. So if I can work out the area of the trapezium, then use the integral and subtract them, it can work. Okay. So what I'm just going to do, just make it easier, I'm going to name my shaded area here A, and the trapezium is going to be called B, so that's going to be red, and the trapezium is going to be called B. Okay, so let's work out B first. So that's going to be my trapezium. So what we've got our different points. So I know this point here is going to be minus 3, 7, and I know this point here is 1, 15. So if I've got my trapezium, I'm going to add the two parallel heights together, divide it by 2, and times by the height. Okay. So I'm going to do 7 plus 15 over 2 and times it by that distance there, which in this case is going to be 4. So we'll end up with 22 over 2, which is 11, times 4. So that part there is going to be 44. Okay. Now I need to do my integration. So I'm going to quadratic, quadratic, quadratic with respect to x, and I'm going to do it between the two limits, which is going to be 1 and minus 3. So let's go through with the integration. Add 1 to the power and divide by the new power. So we'll have 2x cubed over 3 plus, it's going to end up being 6x squared over 2. So we'll have 3x squared plus 7x, and that's between the limits of 1 and minus 3. So we've got to sub in and take away. So we're going to end up with 2/3 plus 3 plus 7. Take away minus 54 over 3 plus 27 minus 21. So we'll have 10 and 2/3 subtract negative 12. So what we end up with is 22 and 2/3. So to find my total area, I've got my two parts here. All I need to do is do my 44, subtract my 22 and 2/3, which is going to give me 21 and 1/3 units squared. Identify your areas first.